All right, so let's dive back in. I'm going to pull up the latest version. The last thing we did for part 3 was we worked on an engineering server. We had a lab environment that we added an engineering server to a particular LAN segment. So the next one in the series, so to speak, is one that seems to be titled HTTP server. So I'm going to pop that up. And for those of you who are new, all of this should look brand new to you, perhaps strange to you, and that's perfectly fine if it does. Essentially, this is our virtual network environment that we've created, that we've built since part 1, and we've just added some new components to it. So in the very beginning of the series, none of the things that I'm hovering over with my mouse pointer right here, whoops, sorry, this thing jumps. Those of you who've been with me are used to my strange mouse that occasionally just likes to scroll down. The rest of you will have to get used to it. My apologies. This section here, which represents the internet and even your home PC, as we like to call it, that wasn't in our first lab. This server here was not in our first, second, or third, I shouldn't say lab, but first, second, or third classes that we've had. But everything else, the router, these 4 switches, and these 9 PCs that I'm hovering over, those were all here from the very beginning. Again, this was also not here, that server. We call it engineering server 1. That was not here. That got added our last class. The reason I'm explaining that is so you don't feel so lost, like, great, I'm late to the game and now everybody's talking past me and I don't get anything. I'd rather not do that to you. So we've got a solid 2 hours to work with. I'm not shy about going past that 2 hours. If you have to leave, it's okay to leave, but I'll just keep droning on. You can ask Jessica or Dennis or Justin or Scott on here. I love to hear myself talk. I'll just go on all day long. So if we go past 2 hours, it'll still get recorded, and hopefully you can, if you need to get your hands on the recording, you can do that to see what you missed. But I'm going to try and get in 2 different labs today. So this one that we have in front of us called HTTP server, and another one that's basically like a trouble ticket. If we're lucky, we'll do that, and if we don't, that's okay too. We'll just have more classes, and until the aliens come back for me, I should be able to keep putting these on as I'm able and as we can schedule them, and we can just keep rolling forward. So I do want a little bit of feedback. At this point, is there anybody that has a question or wants to know something or see something that I haven't specifically mentioned that would help shed some light on anything like that? Pop some questions for me, or at least let me know you're hearing me ask. And if you're ready to move forward, we can move forward. That way I know I'm getting through to everybody, and audio and video and all those fun things are working. All right, fantastic. So I'm going to turn off my face because there's no value in seeing me. I just got to remember how to turn off. There you go. Turn off the old webcam. Okay, good. Now the only thing on the screen should be our, excuse me, Cisco Packet Tracer environment. I am muted by organizer. Well, ladies and gentlemen, I do not have a problem unmuting you. The only downside is if you make a bunch of noise, I won't be able to, or I'll have to mute you again, because you can ask anyone who's worked with me for a long time. I have a pet peeve about background noise. So I've unmuted everyone that I'm allowed to unmute, which isn't everyone. And if you do have some background noise or you can mute, go ahead and mute. Just unmute yourself when you have a question. But you should be good now. All right. You're welcome, Justin. So let's get this ball rolling. Quick refresher again, we have router 0 that does all of the IP routing for everything in this local area network. This is very akin to the size of a small business local area network somewhere. You know, maybe a company that has 20 or 30 employees or 50 employees or something like that. This is the kind of thing that could serve them. It's actually relatively realistic. For those of you who aren't familiar, this emulation software lets you hover over each of these devices, and it gives you click on it, and gives you neat information about those devices, things like IP addresses or MAC addresses, or if interfaces are up and down. It's sort of like a little cheater. In the real network world, there's not something floating in virtual reality to tell you that, although that's a great idea for a patent. I should probably look into that. But it's kind of neat. You can hover over all these things and get some info about them. And what we have and the way our network is built, again, is the one routed device that handles all IP routing. And then these switches do specifically just layer 2 work, layer 2 switching. So these are Ethernet compliant layer 2 switches. And they simply switch Ethernet frames between one location and another, or one interface and another, and that's all that they do. Anything that needs to be routed, any communication from a particular LAN segment, say the one we call the IT segment, it's kind of hidden right here, but it's called IT. And that's the 10.0.0.0/24 space. Anything that needs to leave this space will get switched to that switch, switched to that switch, and switched up to that router, and that router will look at the destination IP and attempt to route it out a different interface to get it where it needs to go. Maybe it needs to go here, maybe it needs to go there, who knows. So hopefully that makes sense. Let me answer all these questions so that when a question mark pops up, I actually know. Stop it. I actually know that you have a question. I'm afraid I'll miss it otherwise. I'm trying to decide how big a fan I am of the fact that I have to click to send my, I can't just press enter to send my answer. I don't like that. You're right, Steve. It would have been funny to wait till I'm in the middle of something to tell me. All right. Good. Apologies again. I know that's a little slow and clunky. I apologize, but that way I can just see the green question mark on my little monitoring screen over here, and I don't miss you. I don't want to miss you folks if you say something, and some people just don't like speaking up. So, okay. So, making some assumptions that we have some general basic layer 1, 2, and 3 knowledge. We're gonna move on with our next lab. So I'm going to read this because the text is probably particularly small on your screens depending on how you're viewing it. So I'll go ahead and read it, and we'll refer back to it as we need to. And if something doesn't make sense, stop me or hit me at the end of this, and I'll re-explain it or however we want to do it. So again, last time last couple of labs, we added some internet connectivity. Then we added an engineering server down here, made up some stuff to do stuff with that. So building on that, you as a network administrator, that's you and me and all the other 9, 10 people on this call, we've been able to convince our company to purchase a proper business internet connection from our ISP. For those of you that were with us before, you'll recall we basically had like a small, not even a small business, but like a home, almost like a cable modem solution. We got one IP address that was dynamically assigned, and that's all we had. It could theoretically change. We had to configure our router to accept a dynamic or DHCP IP as opposed to statically setting it. And we decided to do a grown-up network connection, a little bit more like a business should have. So tonight during the maintenance window, you will reconfigure your internet connectivity and build the necessary components to bring up the web server. There he is, web server 1. The ISP has just changed their IP configuration to the new static IP block and the DNS entry for www.abcplastics.com. So 2 things. 1, our ISP has been, was that somebody needed something? Or did you need me to mute? I'd rather you do the muting so I don't have to. All right. So one thing is our ISP was hosting our web page. We had a web page called www.abcplastics.com, and they were also doing DNS for us. We don't have our own DNS server on site here anywhere. And during this lab, we don't get our own DNS. We're still doing DNS through the ISP. And if my memory serves, I think the address of the DNS servers that we use were 68.188.0.2. I should say are or was, because there's only one in our case. In our example, there's just the one. So let's see here. So that was point number 1. They were hosting our web page, and they were doing DNS for. They're going to continue to do DNS for us, but now we're going to host our own web page. We got a grown-up internet connection. Why don't we have a grown-up web server too? So that's what we're emulating here. Let's see. The circuit has been delivered on the same hardware as the previous. However, the IP addresses will be statically configured as well. You will have a /29 of IP space with which to work. So, couple of things here. 1, because they've changed their configuration for the DNS entry for this web page, the internet can't get to our web page now anymore. So I just muted you, Dennis. Don't be offended. So that's one. And two, because the IP addresses have changed for us, both the gateway that we would point to, which was assigned by DHCP before, and the IP address on our physical interface, which was assigned by DHCP before, those don't work anymore. So actually, our internet's broken. Our web page is down and our internet is broken. So we're essentially, pretending that we're in the maintenance window and stuff's broke now that we've asked for a change to our internet. We're going to make our internet do stuff. We're going to get it all fixed up and working in the new way. So real quick, just to help me gauge the audience that we have, I've made reference to /24s in terms of the IP blocks that we use. And we have a new reference now of a /29. That's the first time it's popped up in our labs since we've been doing these classes. Is anybody not comfortable with what the heck is he talking about, a /29, a /24? Do you want me to go into that very quickly? Because I can. And I can do it rather efficiently without explaining the entire IPv4 concepts. I can break it down pretty simply if it's helpful to anybody. Does anybody have a thought one way or the other? Should we move forward? Should we wait? What do you think? You got to give me feedback or I won't know where we stand. I want to make sure that you're covered.
You're referring to subnetting and different sets of hosts and the word just escaped me.
Yeah, but yeah, in general, yeah, you're absolutely right. That's correct. I'm just talking about subnetting in a very general sense, in a light touch sense, without going into the binary math or any of that fun stuff. I just don't want to assume everybody knows that there's 6 or 8 IP addresses available with /29. I want to be sure that we're including the whole audience. If everybody's like, look, I know what a /24 is, 256 addresses, 254 of which are usable. I know what a /29 is, 8 addresses, 6 of which are usable. If you guys are good, or guys and gals, I didn't look. If you're good conceptually with that, then let's not spend time on it. But if you don't feel comfortable with that, please speak up now. We'll take 2 minutes to just cover that in broad strokes so that everybody's included. So real quick, anybody else? Let's see, Dylan. Dylan's good to move forward. Anybody else? I'm sorry, I'm looking for my virtual pen. It should be in my bag. There it is. For my drawing tool. My apologies. I'm okay, but I don't mind if anybody wants a quick go over. Okay, so again, 2 that are confident or comfortable with the concept. Anybody else, kind of last call, anybody else want me to dive into it real quick with my cute little drawing pad? Or are we good? Scott's good. I think we're good. Don't hesitate to stop, or even if you don't want to talk about it now, shoot me an email afterwards or ask at the end of this thing. We can still do a quick run through of what that means. So I'll get my M&Ms out of the way because they're too tempting and I can't eat food and present at the same time. Sorry. So let's roll. And I'm answering all the thingies. Forgot the unusable network address, IP, and broadcast. Yep, exactly. So that's exactly right. We've got, for any IP block in IPv4 world, we have 2 addresses that are considered unusable by hosts. You can't assign them to hosts. That would be the network address and the broadcast address, both of which in different senses represent the network as a whole. So we won't go into that. Suffice it to say, for our /29 of IP space for our internet connection, we're getting a number of addresses that are static, that won't change, because our ISP promised us as long as you keep paying us, we won't change them, and that can do stuff for us. So I'll just kind of skip ahead and talk about what those addresses are set to be. So 24.217.0.1 is the customer-facing address on ISP's router. And it's already been configured by ISP because we're in that maintenance window and they asked us to do that, right? So somewhere in the ISP universe is a router that has that IP address on it with a /29 subnet mask. Does anybody remember what the dotted decimal notation is for a /29? Ever so quickly, you can type it or you can say it out loud. Again, it's basic, so yep, basic stuff, 248. So 255.255.255.248 is what we call /29. It's another way of saying the exact same thing. And the next address in that block, the first available one, is actually this .1. ISP owns it. They have to own it. .2 is going to go on our internet-facing interface on our router. So router here, cute little triangle, green triangle here, that when I hover over it says I'm fast Ethernet 0/1. That's the name, the official name of the physical interface. We got to put the .2 on there. Well, that's an important point for us to remember. .3 represents the new HTTP server. It's the server that the universe is going to try and get to when they try to surf to our great webpage, abcplastics.com, which, by the way, I mentioned in our last class. Turns out there actually is a real company with that name out in California. I didn't know that when I built these little labs. So hopefully they don't get mad, but I don't think they'll care. We're not saying anything bad. But their network looks nothing like this probably, and I don't think they mind that we're talking about a made-up version of it. So .3 for new HTTP server and .4 through .6 for future use. So that kind of gives you an idea of the available IP space in this /29. So /29, again, it represents 8 possible addresses, the first and the last of which are reserved by network protocol, so we can't assign them. So .0 can't be assigned to anything in this particular universe, and .7 can't be assigned to anything. There's a total of 8 addresses, 0 through 7. One of which goes on the ISP router, the other 5 of which we can do with as we please. 2, 3, 4, 5, and 6. Cool. So, all right, we got our general marching orders. Let me double back and make sure that I didn't miss anything in our instructions. I know I'm moving slow. I'm trying hard to talk slow because I could go through this whole thing really fast, and I know I would be cheating you. In addition, you have been able to secure a server for your company, which will allow you to host your website from headquarters as opposed to paying the ISP to host it for you. Again, that's the server. It sits in a rack somewhere in our corporate office. Oh, I never get this right. It's actually on a table somewhere apparently in our corporate office. Don't ask me why. We put our servers in desktop servers instead of a data center server. Don't ask me why. I didn't decide that. So let's see, the server has been installed in the network and HTML has already been programmed. So the web page, the code for the web page, which is ridiculously simple, has already been put together and put on the server. And it looks identical to the code that was on our server out here when ISP was hosting it. It was a copy-paste deal, I'm just sure of it. So now the one thing I must say, a correction I would make to the instructions is, yeah, it's physically hung in a rack or sitting on a table in our network closet or data center, but it's not installed on the network because it's not plugged in. So that's not entirely accurate. We're going to have to finish that install during this maintenance window. So we need to configure using those IP addresses we talked about earlier. Don't forget to remove the old default route on the router and install a correct default route statically. So some of you might remember that when we had our DHCP activity take place, when the DHCP magic did what it did with our old internet connection, the way this router works, and most Cisco and probably all manufactured routers, it recognized that an advertisement for what default gateway we should use was there, and it actually built an entry in the routing table into the configuration for that static route, for that default route. So we want to make sure it's going to be gone because we're pointing at new IP addresses now, and we don't want to confuse our traffic and send it the wrong way or send it into a black hole because we have extra default routes in there. You can, in fact, configure multiple default routes. Nothing says you can't. So the router may attempt to load balance traffic to a good one and a not good one, or send them all this way, depending on how it's put together. So we just got to be careful to clean that up. So that's a nice little hint. As time goes on in these labs, you get fewer and fewer hints from me because you got to use your brain. Let's see. You have decided to allocate. This is hopefully a place where people are going to start going, wait a minute, what? You've decided to allocate a /24 of IP space for servers in the network. It's going to be our server VLAN and our server IP block, the 172.31.0.0/24 subnet. /24, a lot bigger than /29. Instead of 8 total addresses, you got 256 total addresses. Still, the first and the last cannot be assigned on a host. The rest are available to be assigned, same as we've spoken before. So, at this point, the server needs to live in this 172.31.0.0 place. So after installing an Ethernet HWIC, which just means a WAN interface card, in the router, be sure to configure 172.31.0.1 as the gateway address for the server LAN. So the gateway that we're going to configure is going to be that first usable address, .1, which will hang directly off of the router. There's the router, there's the server. Easy peasy lemon squeezy. Assign 172.31.0.2 to the new server with .1 as its gateway and 68.188.0.2 for DNS, which, as you recall, was the DNS that's being handled by our ISP because we don't do our own DNS here in our little network. You will also need a static NAT entry on your router in order for the outside world to reach the website. What the heck? What? Don't forget that you now have an additional NAT inside interface to declare as well. Wait, what? And then we need to test the connection to the new server from our home PC. Here's home PC out on the internet. And make sure you can surf to the website successfully. Okay, so it got a little sticky there at the end. If some of you have a little bit of smoke coming out of your brains, that's okay. Nothing wrong with that. If you recall, we did build some dynamic network address translation when we got our internet connection last time because all of these hosts here only had one IP address on this interface to represent any traffic that needs to leave and go to the internet. So we had to do some network address translation and actually port address translation to basically overload all the possible translations on that one IP address on that interface. Well, now we got another thing that could possibly initiate a conversation out on the internet, but what's different about this thing than all of the other things that could possibly talk to the internet before that I'm hovering over is this might have traffic initiated from the internet into the thing in this case being web server 1, with a reply going back out. That was not a problem before. All of our configuration before was like your home internet connection. It assumed all traffic would be initiated from the host within the internal network, and it could do some translation and keeping track of translations so that any response would come back and go to the correct host. But we never assumed the traffic would originate from the internet and go down to any of these hosts. In fact, we don't want that from a security perspective in general, because we want to use all the tools at our disposal to protect our network and protect our hardware and software. So we don't want to let traffic just willy-nilly decide it can talk to any host on our network. So while the intention of the overload NAT configuration is not security, it really works well in that capacity in a very general sense. It's not an end-all be-all, but it's a nice layer of security that comes with the fact that you got one public IP address and you got all these computers that want to talk to the internet. So we've got our marching orders. Now we know what we need to do. Let's see if we can roll through this lab and knock them out. At this point, anybody got questions or thoughts? Anybody wanted to say, let's do this first or that first? What do you want to do? You're going to have to drive this ship because without you, it won't go anywhere.
Let's get the internet back up first.
That's a good idea. Might as well fix the internet, huh? All right, so let's jump into router 0. And as I prefer to do, I like to stick it on the screen off to the side here where it's easy to see, and I can still see my topology. Total personal preference. Lots of folks don't work that way, but my brain likes to see pretty picture as well as my CLI. I'm going to say enable so that I can actually do global privilege executive commands on this router. And let's see, I'll just do a show IP interface brief. And I can see that, yeah, my fast Ethernet 0/1 that we hovered over earlier, set to do DHCP, it's physically up. The physical interface and line protocol are up, so layer 1 and layer 2 are happy, but we don't have an IP address assigned to it. And it's kind of consistently asking, hey, I need a DHCP IP. Hey, I need a DHCP IP. So what do we need to do next to get that going?
We need to assign it statically.
Agreed. So we're going to go into global configuration mode. we're going to go into the configuration mode for interface fast Ethernet 0/1, since that's the place that's plugged into the internet for us. And I'm just going to do a quick do, show, run to review what we have in that interface from before. So fast Ethernet 0/1 just says IP address DHCP, IP NAT outside, duplex auto speed auto, pretty simple generic stuff. What shall I type here to correct our problem?
You're going to want to type the IP address that's assigned to us by the ISP, followed by the subnet mask.
I agree. So they gave us 24.217.0.2. And as you mentioned, we have to specify our subnet mask, which was accurately pointed out by Steve is 255.255.255.248. All right. Now we have an IP address on there. I'll do a do show IP interface brief, not because you have to, but because I'm obsessed with always checking the thing that I just configured. I don't know why, I'm just that way. And yet still up, and it's even got an IP address on it. That's a good sign. What do you think? Can we ping the internet from here maybe and see if it works? Does this seem like a sensible thing to do?
Yes.
Yeah, let's do that. So to us, the internet is that gateway address they gave us of the .1. That's the first hop on the public internet, the wild west of communication. So I'm just going to try and ping that address and see what happens. Not shockingly, it takes a second to get going because there's some MAC address learning that needs to take place, and ARP that needs to take place, and then everybody's happy. So I am pinging our interface right here on the edge of the internet. That's a good sign. I'd say we configured it correctly. I think that's good. What do you think? Should we try to hit something further on the internet and see if we can hit it? And if so, why? Why would we want to check that, do you think?
Yes, I believe we should check that, mainly because making sure that the routing on the ISP side is working properly as well.
Yeah, that's exactly right. So Jeremy's right. The point is, if I can ping my directly connected interface, no problem. That's generally speaking doesn't require anything but IP addresses configured on each end and things plugged into each other, which we can see from our pretty picture. They're plugged in and they're green. They're happy. But yeah, I don't know what the internet at large is doing for me or if it's working all the way. Is the ISP telling the rest of the world that, hey, if you want to get to this 24.217.0.0/29, go this way? We don't know. So let's check it. So let's try the one public IP we know exists out there that we've used before and we're still using. Let's try that DNS address. So let's ping 68.188.0.2. And because we are, let's see here, what's happening? No, it's not happy. Definitely doesn't like that. Can I source ping? I don't think I can. Let's try it this way. Ping, we want to use IP protocol. We're shooting for 68.188.0.2. Let's do it 5 times. Yes, I want some extended commands. Let's make sure we're sourced from 24.217.0.2. It should do it anyway, but just to make me feel better, we're gonna do that. Yeah, it's still not happy. The question is it a bug with my packet tracer, or did we not configure something? Oh no, let's think about that for a minute. What can we check on our router to figure out what might be happening here? Anybody got any ideas?
Shouldn't we take a look at NAT maybe?
We definitely could. It's not a bad idea, but let me ask you this question. If I'm egressing this interface headed towards the internet, and the IP of that interface is a public IP like 24.217.0.2, is NAT necessarily involved, or does it necessarily need to be involved?
Yeah, you have a point there.
Yeah, it doesn't. It doesn't, but it's still a good thought. It's a very good thought. Well, let's just ask the router, look, tell me about where you're going to send traffic if I try to send traffic places. Let's just start there. So I'm going to ask the routing table, show IP route. Let me just see the routing table. And what we see is my router knows about the 10 dot network. It knows about the 24.000/29 network because it's directly connected. It knows about the 172.16 because it's directly connected. And it knows about the 192.168. But you know what it doesn't know? It doesn't know how to get to 68.188.0.2. It has no clue which direction to send it, does it? So Scott has kind
Yeah,
of
the gate.
go ahead.
Sorry about that. I talked over you, but I just noticed that the gateway of last resort is not set, so maybe we need a default route.
Exactly, which is what Scott mentioned too. We need a default route for sure. So let's get one in there. So back to configuration mode, go configuration mode. And how do we set a default route on a Cisco router?
You have to use IP route, and then you do all zeros for the destination prefix. You'll do all zeros, and then the same with the subnet mask.
Mm-hmm.
And then for the second part, you'll use you can either do the interface, or the exit interface, or the IP.
That's
For the
correct.
next hop, I'm sorry.
No, that's fine. So yeah, we got two choices. We can either specify our exit interface or we can specify the next hop IP. There's different schools of thought on how or why you would do it the way you would do it. Best practice tends to be to specify the IP address. But that doesn't make using our exit interface any less legitimate. But we'll go ahead and do best practice here. So what's that next hop supposed to be for our
That dot one, that dot one address from the ISP.
exactly. So we now said, hey, if I'm trying to send traffic to G I don't know IP address with G I don't know subnet mask, send it towards this next hop address. That's what we're telling it to do. So now if we do show IP route, our routing table now has better information than it had before. If you're not sure where to send traffic, send it towards this IP. Well, we know where this IP lives because it lives here in this directly connected off of my fast Ethernet 0/1. So there's actually two routing table lookups that take place when we say, hey, ping 68.188.0.2. First it looks, do I have an entry for the 68.188.0.2 type network? No, I don't. Well, what do I do? Crap, I'm out of choices. My option is gateway of last resort. So let's see, I got to do this. So do I have an entry for this? And then we scan the routing table and then we learn, here's where that's connected. That's connected to my fast E01. Let's send it out that way. So there's two lookups that happen, which is something that doesn't happen when you configure the interface instead of the next hop. But it's a process that they're well designed for and they work well for. And the one thing it gets you is if for some reason we unplugged the cable and plugged it into fast Ethernet 02, if it existed, which it doesn't, and put the right IP on there, then we wouldn't have to reconfigure our default route. That's one reason why people like to use the next hop. So now we think we know where to send traffic. Let's try to ping that 68.188.0.2 again and see what happens. Maybe some ARP, maybe some MAC address learnings, all that fun stuff, but now we're pinging it. It's a good sign. So our internet connection seems to be working. We're getting out to a remote destination on the internet and getting a response. That means that our ISP is in fact telling the world, if you're trying to send traffic towards 24.217.0.0/29, come through me because I'm going to send it out my whatever that interface is towards us. So I think we got that part nailed down. So the internet is quote unquote fixed from that perspective. Excuse me. So what else should we do? Should we test from a PC to make sure the internet's fixed and happy? Because it works from our router, but we haven't tested from anything behind the router. You know what I'm saying?
Yeah, I think that would be a good next step.
Yeah, let's do that. Let's grab PC8, make sure PC8. We're just going to do some standard pings for now because the one web page we've been using we know isn't quite working right. All right, so make sure I got my questions all caught up here. Oh, I think I'm doing something wrong. I am. I'm messing up the question and answer excitement. It's like duplicating the question over and over in my screen. Sorry, guys. Steve, I'm not ignoring you. I just can't get the stupid thing to work right. So I'm not messing with it anymore. All right. So let's try to ping 68.188.0.2 from one of our LAN PCs in the IT department, and boy howdy, we got an answer and everything. That's a really good sign. For grins, I'm going to do a trace to that same IP just to see what the trace looks like. Is it 10 hops, 20 hops, 100 hops, 1 hop? I don't know. Let's see. All right, we go to our gateway in our subnet because we're the 10.0.0.0/24 subnet. Then we go to 24.217.0.1, which lives over here. And then we go to 68.188.0.2. So cool. So wherever that lives, it must live right off that first internet router. How convenient is that for us? All right, I'm pretty stoked about that. That's a good sign. Internet seems to be up and running again, so good. One thing that was broken is now fixed. What should we do next?
Let's set up the web server.
Yeah, let's get the web server rolling. That's the other thing that's broken, right? Web page is down. Right now, no one can surf to our super awesome web page. So what do I got to do first to make that happen? Where should I go first?
Get some cable.
That.
Sorry, say that again. You got two of you at the same time. I apologize.
We got to install the HWIC card in the router if we haven't already done so.
Yeah, let's have a look if we have or haven't. Show IP interface brief. There is no available interfaces from what I can see. But let's look at the front face of the router specifically. Physical. Zoom in, and I apologize. It probably doesn't show up very well on your screen. But basically, we've got a fast E00. We've got a fast E0/1, which is mislabeled in our cute little picture. And then these are console and auxiliary, so we can't use those for our purposes. So we don't have any place to plug our server in at all. So let's get a card put in there. We got a selection. Let's see, did we specify? I didn't really specify, but I'll be honest, I always go for the 4-port Ethernet switch one because it gives me lots of extra ports for later. So I'm going to use that one, okay? So let's plug it into slot. There's a slot 0 here and there's a slot 1 here. I'm going to try and plug it into slot 0. And it says, no, I don't think so. Cannot add a module when the power is on. Okay. So what should we do so we can install our card?
We have to switch off the power to the router.
Turn off the router. Because, yeah, there's the physical switch, so easy to do. Anybody else? Everybody cool with that? Should we go ahead and turn the router off so we can install the card?
Should you gracefully shut it down first?
As far as gracefully goes, there's not a shutdown for the router. There's not a, hey, just turn yourself off and don't turn back on. There's only a reload command that we can issue from CLI. So, no, as long as everything's, we're content with the way everything's set up, we could be good to just flip the switch.
I just remembered we should save the configuration.
I was going to let you guys tell me to reload it or to turn it off without doing that. That's exactly.
Yeah, I just had the thought in my head.
Good, because yeah, we'd had to redo all that. So good. Now we did a right mem, which is really the important thing, and now we can safely turn this bad boy off. So I'm gonna flip the switch. I'm gonna grab the card off the shelf. I'm gonna plug it in. Now it's happy. Now I can flip it back on. We've got 4 Ethernet ports to work with. Happy times. Copper Ethernet, I should say, not just Ethernet, but copper Ethernet. And our bad boy should be reloading now, and the nice part about our environment is if it takes too long, we can use the speed up time button. But we don't even need to do that because it reloaded pretty quickly. So let's see, did we save our config? Did we get it right this time? Let's see. Yeah, 24.217.0.2 is still there. Now we've got 4 new interfaces to work with. Fast Ethernet 0/0/0 through 1, 2, 3. The extra slash is for the chassis number, then it's slot number, and then it's module number. I think that's, or not module number, but interface number. I think that's right. So cool. Got some fun stuff to work with. Let's see. Let's double check. Show IP route. Do we still have our gateway of last resort? Why, yes, we do. Can we still get to the internet? Because that matters. We can. Okay. So I feel like we did good saving our config. Well done. Thank you very much, guys. You saved probably 5-10 minutes just on that alone. Let's see. We got the card in. Now what do we need to do? I got lost in my own train of thought.
Need to connect the cable from the router to the server.
Absolutely agree. In the old days, it mattered. It doesn't matter as much anymore. But what kind of copper cable do you need to go between a host and a layer 3 device like a router in the old days? Was it a straight through or a crossover?
I want to say crossover.
I want to say you're right. Yeah, that's exactly right. Crossover was with like device types, like layer 3 devices. You'd have to do a crossover. Two layer 2 devices to each other, you'd have to do a crossover. A layer 2 device to a layer 3 like device, like a host or a router, you could do a straight through. That was the way that was intended. That's the way the pinouts worked in the old days. Now it just doesn't even matter. Yeah, so crossover for NIC to NIC was what Steve said. That's exactly right. So whoops. So let's do crossover because we can, not because we have to. So I think 000, if you guys are good with it, we'll just plug it in there. It's as good as anything else, right? Looks like he's saying, yep, I'm good to go. I'm ready to rock. I got electricity. So that's a good sign. So now, yeah, we're physically plugged in. So what's next? As obviously you can see the orange here means spanning trees doing its job and protecting the network for a little while before we load up. We talked about that at length in the other classes, so we don't have to go into it right now. If you have questions on it later, feel free to ask. Don't be shy.
Need to assign the IPs and the subnet.
Yes, let's see, where do I want to do that?
On the router 0/0/0.
All right, let's see. So back to global configuration mode, interface configuration mode for fast Ethernet 0/0/0, as I believe it was Scott or somebody just said. And then I have to, what is it? IP address, right? And then
Yes.
what are we trying to use here?
Let's see. Well, didn't you say the new HTTP server is in the cloud? So that's not the address. Can we see it there? I think it's
Whoops.
probably
Yeah.
below where you.
So let me move the router out of the way for a second. So in our public IP addresses, we reserved 24.217.0.3 for new HTTP server, but then also down here it said assign 172.31.0.2 to the new server. With that one as the gateway and so on and so on. That one is the gateway. So the question is, what goes on here? That's a bit confusing, isn't it?
Yeah, a little bit.
That's okay. It should be. If you've never done it before, this should be very confusing. Let me scroll down to my questions here and see what I've missed. Somebody said something. No, I think I've covered all the questions. Where's Dylan's remark? Oh, right there, crossover. Okay, gotcha, got it. Bear with me.
Do we need to, don't we need to configure maybe a virtual interface for the switch ports to connect to? I've never configured an HWIC card before, so
You're
kind of spitballing ideas.
Yeah, your instinct is correct. That's exactly right. Turns out we can't, and we're going to find this out as soon as we hit enter. I can't do IP address on this port at all. I can't do any IP commands on this port at all. And you really, the hint is in the fact that it's an Ethernet HWIC. That these are essentially switch ports. These are all switching commands for the most part. Switch port this and switch port that and spanning tree and all that fun stuff. It's very much switch-like. So basically what we've done is we've installed a little miniature 4-port switch inside the router. So we have to pretend that this is almost like its own standalone switch in that sense. So how can we do that? How can we get what we need to have happen if I can't put the IP address on this physical interface fast Ethernet 0/0/0?
We need a virtual interface, correct?
Yeah, absolutely. Let's do that. Let's create a virtual interface. So what I think I want to do is we have the 192 VLAN, the 172 VLAN, and the 10 VLAN. The space for the servers is 172.31. So why don't we just do VLAN 31? It's not pretty, but at least kind of in our heads it'll make sense. Is that cool with everybody? Nobody's objecting, so I'm going to take that as a yes. So let's do that. Let's create a switched virtual interface, an SVI. We're going to call interface VLAN 31. And what we're creating is something that's not physical. We can't touch that interface. We can't do anything with it per se. but it exists virtually inside the router. The commands we can use on an SVI, or what people like to call interface VLAN, which is really a misnomer. That's not correct. Now we can set it. You'll look right there. You got IP as an optional command, so I can set an IP address on this interface. So now we should be able to set it. So we're on the router for the server VLAN. We decided to call it VLAN 31. So what IP address should go on the router for the server VLAN?
172.31.0.0.
So 00 is a reserved address. It represents the /24, that whole network as a whole, but you're very close. What did we say?
So 02. Oh, one is the gateway.
Yeah, because the router represents the gateway for the server to get out to the rest of the world, right?
Correct.
That's exactly right. Let's put .1 on there. So 172.31.0. Whoops. .0.1. Ooh, if I could type, I would be a pro. I know it seems like I'm. There we go. And then the subnet mask for /24. Easy peasy. 255.255.255.0.
You got an extra number in there, Hunter.
Yep.
Surely do, Shirley. Thank you so much. Good eye, good eye. All right, cool. So now the gateway address for that VLAN, anything that wants to exit that VLAN, go to the rest of the world, we have set it. I can even do a do show IP route, and there's another entry in our routing table. Wait, no, there's not. Oh, there's not. That strikes me as odd. Let's exit out of here. Do show IP interface brief. Ah, well, that's why it's not in the routing table. It's down. Huh. So I can't see it in my routing table because that SVI VLAN 31 is down. Maybe we need to do a no shut on that. What do you think?
Yeah, because it says manual down, so I would assume it would be a no shut command to bring it up.
Yeah, I think that's reasonable. Let's try it. No shut. Normally it says like line protocol and all that stuff. Nope, she's still down. Now, why would that be? Any ideas?
Well,
Could
if
it be
the
'cause
status is
there's no
down, it's
switch
usually a physical problem, isn't it? Or that's a good place to start.
Say that last part again. A good place to start was what? Say that again. I think it was Steve.
If the status is down, usually I'd want to look for a physical connection missing.
That's not an unreasonable thing. And then someone else, Jeremy or someone else, had a thought too that I think was correct.
Yeah, don't we need to assign the VLAN onto the port?
Yeah, think about it.
The port doesn't know what VLAN it is.
Yeah, there are no interfaces. There are no physical interfaces on this router that participate or live in that broadcast domain in VLAN 31. If you have no interfaces in VLAN 31, your SVI won't ever come up. It's intentionally down because we don't want a black hole traffic trying to get there. So yeah, we got to put an interface into VLAN 31. Which interface would that need to be in our case?
That's 000.
Yeah, all zeros. Interface fast Ethernet 0. Whoops. 0/0/0. Remember, we couldn't do IP address. That wasn't even an option, but we can do switching commands. What's our best bet?
We want switch port mode now.
I like switch port
Hey,
mode.
go ahead.
Put it in access mode.
Yeah, because it's just a single host plugging into it, right? Not like another switch or anything like that. Cool. I like it.
And then switch port access VLAN 31.
I think it's
Do I
really,
sound okay, by the way? I've got my microphone kind of.
sounds good. Yeah.
Okay.
Yeah, sounds good right now. Wherever you're at setting right now, it's pretty good. At least from my perspective. Thank you for asking. So yeah, and Dylan was on top of it too on the side. I just didn't see his answers over here, but you're absolutely right. Switch port mode access, switch port access, VLAN 31, and you notice as soon as we did that, the SVI VLAN 31 went ahead and came up. So once we had an interface that came alive in that broadcast domain, that SVI said, oh, okay, now I can be alive. Now I can be up. And you notice what happened here. why did this go orange? Why did we suddenly encounter a spanning tree thing where we had to go orange again, or amber technically? Why did that happen?
You change broadcast domains.
Yeah, you change broadcast domains, you change your layer 2 topology. You cannot escape that reality. And the minute you change layer 2 topology, spanning tree goes, hold on a minute. Let me make sure that we're not screwing ourselves over here and creating a bridging loop. I'm going to do my spanning tree thing. Everybody else wait just a moment while I do it. So excellent, excellent. Spanning tree topology changes are the kind of thing that is easy to overlook when you're just setting up some access ports or popping a server, and the next thing you know, disaster strikes, or at a minimum, you didn't realize that you could impact the entire VLAN. It is potentially possible if you plug the right thing in with the intention of being, it's just this one port, it's just one little thing. Heck yeah, dude, you could have orange all over this board if you do it just right. So good, awesome, you guys are right on point. All right, cool. So now let's look at that routing table. Do I actually know about a new subnet this time? Now we do. I have another directly connected subnet, whoops, right there. It's the 172.31.00/24 network, and it is directly connected on the interface called VLAN 31. Instead of fast Ethernet something or other, it's VLAN 31. So cool. I like this. This is progress. Let's see. What else do we need to check in terms of this SVI and physical interface configuration and the server configuration? Is there anything else we need to do, or are we done with the server part?
I was messing with my microphone a couple of minutes ago, but did you put an IP address on the server itself?
I'll be honest, I don't remember doing it. Why don't we just jump over there and look at it real quick?
Okay.
Let us see what we see. Okay, web server 1. It looks like that. Fancy, shiny, exciting. And in the configuration, we have the fast Ethernet 0 interface, the only copper or physical interface on this box. And it is set to do DHCP, so naturally that's not going to work for us. What do we need to pop on that bad boy?
Which one was that? The 24.17.0.3 was it?
It's 24.217.0.3. Was that? That's what the instruction said. I'm kind of hovering. I know the print's real small, so it's okay if you guys can't see it. Don't feel bad.
Yeah, I knew it was somewhere in there.
Something like that, and that would be a /29, which was accurately pointed out earlier, is a .248 for the subnet mask. Okay, I'm cool with that. Everybody else cool with that? Is that good? Happy? Give me some feedback here. What do you think?
I thought that we were supposed to assign it 172.31.02.
Well, let's see.
Down at the bottom there, I thought.
Yeah, right here. It says assign 172.31.0.2 to the new server with .1 as the gateway and 68.188.0.2 is for DNS. Now, I'm not saying Steve did something wrong or was thinking wrong, because it says right here, 24.217.0.3 new HTTP server. So it's not like Steve's crazy and he's the crazy one in the corner talking to himself. It said it right there. So what the heck? What gives? Which one am I supposed to friggin' use? Because now my brain hurts.
You need to use the private one inside the network, and that's going to be the public address.
That's exactly right. That's exactly right. That's what it comes down to, and that's why this is confusing, and it should have been confusing. And I'm thrilled that we're having to debate it a little bit, because this is the crystallization and the learning part. Like, the light bulbs are going to be coming on here for a lot of folks, which is awesome. So because we set 172.31.0.1 here on our SVI for VLAN 31.
Oh, the SVI address.
We got to make sure we live in the same subnet, right? Or he'd never be able to communicate. If we leave it as it is right now, let's say 24.217.0.3, and we set our gateway to 24.217.0.1, which would have been the natural gateway. I'll leave DNS alone for now, and we go to ping. Let's try and hit that 24.217.0.1. Let's try to hit our gateway. And this thing will go long. It'll never work, right? Because it doesn't even know how to communicate with those things. And if you look, it'll never get an ARP entry for that. because the next directly connected interface is never going to answer to that IP address. Well, must not be for me. I'm going to ignore it. Another one must not be for me. I'm going to ignore it. So yeah, we live in the same segment. We got to live in the same subnet. That's the rule. So good stuff. So let's go back and say 172.31.0.2 we said. And of course the subnet mask should be, instead of a /29, should be /24. Cool? Now, can I ping my gateway as the server, my friend at .1? And by golly, we sure can. And we got an ARP entry for it. It's the, let's see, 177E.3801 MAC address, which is, get my router back up here, do show interface VLAN 31. Yep, our SVI is right there, matches up. We are cool. We are communicating with some stuff. That's awesome. How about the internet? Can I ping the internet? Let's try the 68.188.0.2. We know it works from the router, and we know it works from LAN segment PCs. We tried that earlier. Let's try it from here. Thinking. Why isn't this working? What is happening? No.
Well, being on a privately addressed subnet, we have to translate it on heading out of the router to the internet.
Yeah, that's a good point. That's an excellent point. Well, when we did it here, when we came from the 10 dot space and went out to the internet and came back successfully, that tells us we did a translation there. So yeah, I think we just need to make it happen the same way. So let's look at this. Let's see, show run. Let's see. I should do show run. And let's find the IT network is the 10 dot network. We called it VLAN 10. Aha. There's our hint, right? Got to have an inside interface gets natted so that, or excuse me, we have to specify that there's an inside interface so that the NAT action takes place. It takes place for VLAN 10, no problem. It takes place for VLAN 172 and 192, no problem. That's why these PCs and these PCs and these PCs can talk to the internet. But we didn't do it for this fellow over here, did we? And that was actually in the instructions. There was a hint in there. Don't forget you have an additional NAT inside interface. It's kind of right there, kind of half covered up. So good. So good point. What do I need to do? Walk me through it.
We need to go to interface VLAN 31, wouldn't it be?
That's one possibility, or could be fast Ethernet 000. Which one's better?
Well, F000 doesn't actually have an address, does it?
You're right, it doesn't. Let's look at the config on it real quick. Do show run. I kind of skipped it. I could have gone one more click and you would have been able to see it. Yeah, there's no IP commands on there. So would an IP even work? Could we even set it? As soon as we type IP NAT, the thing's going to say, no, you can't do that here. Can't get there from here. So yeah, so we got to do it on our, where's it hiding? On our, it's in front of me, I know, on our SVI, on our virtual interface. You're absolutely right. So your instinct was correct. Interface VLAN 31, IP NAT inside. Now it's an inside interface. So let's do a quick show IP NAT. Is it translations? No, statistics. And you'll note, here's all of our inside interfaces that we specified. .10, .172, and now our 31 happy time. Here's our outside interface. No shock, right? The outside interface is the one that's plugged into the internet. Cool. Now it should probably work, right? Because now we know that NAT translation should happen.
Isn't there something we need to do extra, though, for the HTTP's public IP in order for that to translate the new public IP correctly?
I think you're correct. However, for the sake of us testing, can this device get to the internet and back again, we don't. But your instinct is dead on. There's another step we need to do, but it doesn't have anything to do with our trying to get to the internet and back again. It has to do with the opposite. That thing that's unique about our web server, the internet trying to get to us first and then us going back. Anything initiated from outside. So yeah, let's come back to that though. But let's at least make sure we can actually just get out and back again, like any other host on in our local network. that make sense?
Yep, that makes sense.
Perfect. All right, so let's go back to our pinging something we know is remote and see what happens. Still not happy. Yeah, still not happening. All right, we're not there yet, but I know we're close. Any thoughts, anyone? Did I get some more participants in here? Sure did. Drawing a crowd. Yeah, baby. What else do we need to check? Why is this not working?
Don't we have to create like a source list or something? Like a translation from the inside to outside?
Well, essentially we've done that by adding this to our list of inside interfaces because, no, actually, hold on. Maybe not. Here's our NAT translation right here. This is the overload translation we did for all three of these subnets, and now we're trying to add a fourth. So you guys are all on point. I dismissed your thought ahead of time. What we're saying is, hey, anything coming from the inside, which is what we're trying to do, let's make the source be of this list. If it fits in this list, go ahead and translate it to this outside address. And because it's going to be more than a one-to-one, you got to overload it. Otherwise, it'd just do the first one and nobody else could talk to the internet, right? So let's look at that private to public list. It happens to be an access list, and it just happens to be on a screen in front of us. And you folks are absolutely right. I sort of left something out of here, didn't I? What do we need to slap in there real quick?
The new network.
Yeah, 2 seconds, we do it, knock it out. Whoops, config T, IP access list standard, private to, I'm doing this the harder, longer way, pub overload. You copy paste into Notepad and back again is actually better. In fact, instead of me risking making a mistake and breaking everyone's internet, why don't we do it a best practice way? Let's just grab this real quick, copy, and can I type the word Notepad here? No, I cannot. They've locked down our computers here to where you can't hardly do anything. Windows
Oh, it did start typing.
Notepad. Here we go. That's okay, I got it. All right, can you see my Notepad okay?
Yeah, it's there.
Okay, cool. So I'm just going to permit the next address, right? And the inverse mask for /24 is 255 or 000255, just like the others. So that's kind of super easy. So we're very lucky. So the reason we do it this way and basically completely overwrite the other is so we don't accidentally wipe out entries. And then again, if we're configuring this remotely for some strange reason, which we shouldn't be because the internet was broken and it's a maintenance window, we should be sitting at the office. But for some reason, we don't accidentally lock ourselves out. If you play with your NAT translation list from your outside to in stuff, you're going to break your outside to in connectivity if you're not careful. So best practice, just put it in Notepad and copy paste the whole thing. We could have just added the single statement, but I'm not going to play around. I'm just going to do the whole thing. So select all, copy, go back to my friend here and paste. Boom, there it is. All right, so show IP access lists. Cool, very good. This one we're not worried about. That's from another, our prior lab. But now our entry's in there. We should be good. Let's put that away. Let's get our server back out. Let's try this again. Can I ping 68.188.02? Why, yes, I can. All day long. Very nice. That's a good sign. We're getting to the internet and back again. Now, there is something we didn't configure correctly on this server that could come back to bite us later. Does anyone remember what it is? Check it out. We still had that other gateway entry here. It was actually, my expectation was it wouldn't work. I'm surprised that it did. It should actually be that .1, 172.31.0.1, and then our 68.188.0.2 for DNS. Now we've followed the instructions and configured it correctly, but it's cool. Just for grins, we'll double check that in the services that we're running, we do have HTTP turned on, as well as HTTPS, the secure version. And we have a web page that says index.html, and if I click on edit, there's the HTML code. Extremely simple, but it does the job for our fun, exciting stuff, right? So cool. I think we're done with the web server. It's plugged in. We're all green lights. We can communicate to the internet and back again. Now it's more on the lines of what you guys were talking about repeatedly, which is absolutely correct, is there's something special we have to do for NAT. It's not as simple as a new host on our LAN segments, but this is a special kind of host, the kind of host that the internet will initiate traffic to more often than not. We need a special NAT. So where should we do this special NAT?
Well, we need to relate the source access list with the VLAN 31 interface to the outside NAT interface as a static, right?
Yes and no. So it's kind of interesting. We've sort of already arranged our interfaces in deciding what's inside and outside, and those generic commands, IPNet inside and outside that we did, they sort of cover us from that perspective. We're sort of already covered. But the relating piece you're talking about is that static NAT, not a dynamic overloaded NAT like we did here. It's more of a static NAT. So the principle is the same as what we did for our NAT before, but it's specific to, if you're trying to get to one address as your destination, I'm going to change it to this other address. So what IP address is the world going to try to get to us on? If you're out in the world trying to get to our web page, what IP are you going to hit? Is it 172.31.0.2?
No, they'll use the 24.17.03.
Exactly. That's the public one. That's exactly right. So that's where our NAT needs to happen. We need to say, hey, if you're headed towards 24.217.0.3, translate that destination to 172.31.0.2. So it has to happen on our only layer 3 device. So as traffic comes from the internet headed towards our server at that 24 address, we're going to recognize that, oh, well, there's nothing really configured with that 24. It really needs to be configured this 172.31 thing. It does the translation, then the packet hits the routing table and makes routing and forwarding decisions, and then it goes to where it needs to go. And even better, because we write that static rule, it automatically knows anything going this direction, that's this particular 172.31 address, it also translates it back the other way. Whether there was a traffic initiated or not, it's smart enough to go, oh, well, you must mean for the rest of the world, you must mean that you're actually 24.217.0.3. So you're absolutely right. If we go back to our actual command, show run, let's do it this way, show run pipe include NAT. It's a little easier to read. This is what we wrote for our dynamic overload NAT fun excitement. Let's do something similar for our web server. So we're going to say IPNAT, no big surprise, in global configuration mode, and I'm actually going to specify inside, because we're going to be looking at this from the inside perspective, even though it's going to work in both directions. Whether this is the absolute best practice in the universe, I don't know. But I know it works, and I know that's how I've seen it implemented in other places pretty consistently. So we're going to say IPNAT inside, and our choice is we're going to translate the source address. So it's specific to coming from the inside, headed towards the outside. Well, then it has to be source address you're translating. If it were outside, it would be the other way. We'd be focused on destination. So we're talking about if you're coming from inside, headed towards outside, change the source address to something else. But because it's basically not backwards compatible, but vice versa compatible, for lack of a better term, it'll actually flip it the other way and consider it from outside to in as the destination on the way in. It works both ways. It's a quirk of the software. My opinion, I think I said this on at least one of our other labs, other classes, the way that this syntax is worded is horrendous. It is super hard to understand. It is super hard to wrap your brain around. You got to do it about 500 times before it ever sticks. It's random. There's no logic to the way the order the words are in. I think it stinks, but it's what we have to work with. So IPNAT inside source, and now we got some choices. Do we want to do it from a list like we did private to public overload, or do we want to do static? Well, it's a local to global mapping static because it's just the one server to this one public IP address. So let's do.
Yes.
All right. Now, inside local IP address, what would that be?
Your 172.31.0.2.
Yeah, absolutely. That's the one that's very inside, very local to our network. That's exactly right. It says, okay, fine, then what's your inside global IP address? So all it means by inside global is because it's the source we're tweaking in this particular configuration, not the destination. But the global is the dead giveaway. So what's the global IP address that this should get translated?
24. Go ahead, Jeremy.
That'll be the 24.217.0.3.
Yeah, absolutely. And that's all we have. That's all we need to say. I want you to change my inside source address from this to this. It's a static translation, and we hit enter, and that's it. So if I do a show IP NAT not translation statistics, nothing really changes, right? We're still got the same interfaces participating. That didn't change. But if I do translations, now we haven't recently communicated with anything inside or outside of our network, but there's one that's just already built and sitting there, and it never goes away and it never times out, saying if you're a global address, it's the .3, it gets changed to the other global, the local address, and vice versa. That's what that implies. It doesn't read well, but that's what that implies. So let me, just for sake of comparison, let's pop this PC8 again real quick that we played around with earlier, and let's ping some stuff real quick. Yeah, let's do the trace because that'll generate some stuff. Hopefully we didn't break something. There we go. So that should have kicked off some translations. Yep, there you go. So a bunch of translations. 10.0.0.2, port number 17 as it turns out, tried to talk to 68.188.0.2. And out on the internet, you didn't have to change your destination. It was already a globally unique address. But to the rest of the world, 10.0.0.2 was represented as 24.217.0.2. Well, you recognize that IP address, don't you? What's that?
The internet-facing port on the router.
Yeah, it's this guy right here, exactly. But notice this one's still kind of sitting here doing nothing, but always available. Now these will time out after a couple minutes and go away. It holds them open for a while because it tries to assume, oh, you might be having a TCP conversation. I better hold this open for a bit so you can do your talking. If it notices it's quiet after a while, they eventually time out. I don't remember what the timer is on that, but I know they'll time out in just a couple minutes. So cool. But again, let's get back to the whole purpose. What was the whole purpose of creating this static rule that we created right here?
For outside access from the internet.
Exactly, from traffic originating on the internet headed towards our server. Exactly. So let's test that. Did we make it work? Only one way to find out, boys and girls. All right, let's see here. So this is my PC at my house. And I'm going to start with some basic pings and stuff because I want to know that that works. Let's see, IP config, what is my gateway? My gateway is 15.15.15.1. Okay, make sure I can ping my gateway. Ooh, just because I'm a bit anal about it, and because I think we talked about this lab, because we start it from, we turn everything on at the same time. It's not like it's been running for years. It has the quirky characteristics of some Mac and ARP learning that has to take place. So, good, we can hit the internet in general. Let's see. If I ping, I know the IP address of the web page used to be 68.188.0.2 because the same server that was doing DNS was hosting our IP, or excuse me, our web page. Can I ping that? I can. So, but wait, we have a new IP address for it. So how can I check to see if that's now a new DNS entry? Because it said in the instructions they changed it, but how can I check that? Any ideas?
By pinging the web address.
Yeah, I think so.
Of the server.
Yeah, so www.abcplastics.com. And if it replies back saying, hey, you're trying to hit 68.188.0.2, well, then the ISP didn't do their job like they said they did. But if it replies back with something else, then maybe they did. So let's see what happens. All right, look at that. Right out of the gate, we get 24.217.0.3 as our destination. It translated that to that. So that means the ISP did update DNS, thank goodness. And we're even getting a reply. I'm pretty stoked about that. That's a good sign. So what else do we need to check to make sure that this is actually serving up our web page?
Try to pull it up on the desktop.
Yep, let's pull it up on web browser, kind of tucked in over here. www.abcplastiques.com. Hit enter. Boom, we get it. We know that's definitely the right one because we just saw DNS do the job and send us to the right place, and we got a response. So we know that our translations had to be working. And in fact, all these timed out, and they're gone now. And we got some new ones. We got those pings that we sent through, and we have a TCP conversation sourced from 15.2 on source port 1025, headed towards 24.217.0.3, destination port 80, which is HTTP. Got translated to 172.31.0.2, same destination port, which is HTTP. So that's a really good sign. The web page worked. The translation seemed to work. We can communicate in both directions. We can still talk to the internet from our other stuff. Is there anything else in the instructions that we're missing that we should do?
I don't know if they were in the instructions, but we need to know if we can reach the web server from the internal network still.
That's an excellent question. So let's try it. Actually, let's back up a step. Let's go here. www.abcplastics, just like we did on the home PC, right? Interesting. What's happening here?
So the router is only translating it to that address from the subnet that goes to the web server, not from the one going down to everybody's PCs.
Well, you're close. You're really, really close, and you're hitting on what the problem is. It is a NAT problem in a sense, right? The problem is the only traffic destined for 24.217.0.3 that gets translated to 172.31.0.2 is traffic that comes from here headed into our router.
Because right, not from the other side.
Exactly. That's the NAT outside interface. These sub interfaces here, say for like VLAN 10, they're set as inside interfaces. So there's never going to be a translation for that. So really, there's something else that's wrong with this picture. You're right in why it's not working, but what's really instinctively, something's wrong with this. Does anybody have an idea of why that doesn't make sense at all?
Well, it makes sense of why it's not working.
Mm-hmm.
Just not sure what the best way to go would be to go about making it work.
Exactly. So this is the part where there's an issue. There's something wrong with this output. This should not look the way it looks. Why is that?
They're not participating in that VLAN?
No, that's not an issue. All the routing between VLANs works just fine. You're headed in the right direction, although I don't know if you realize it yet. This output
would it be stupid to give it another DNS entry?
You're exactly right. It's a DNS problem. The problem is this. The problem is that these are inside hosts inside our private network, and so is that. So why would we be trying to hit, hey, where'd you go? Why would we be trying to hit the public address for something that lives inside our network, right? The inside-outside boundary is right here at this router, essentially through that outside interface and, in a sense, that NAT translation. So we don't ever need to hit the public interface. In fact, we never do hit the public interface because the router sees our request and, well, it tries to send it that way, but it can't. Because there are no interfaces, there are no devices that actually have 24.217.0.3. It doesn't exist. And that's one of the interesting points that I think is lost on people when they first start doing NAT or talking about NAT and the way NAT works is, you mean you got an IP address that you have reserved for a device. It represents that device. People send traffic towards that IP when they want to talk to that device, but neither that device nor any other device actually has that IP address? What? That's insanity. No, it turns out nothing has that IP address. We just got a router that ambushes that traffic and says, oh, you mean to send it here. I'll fix that for you, and vice versa on the way back out. So the issue is we're inside hosts. I should be able to ping directly to that server's address instead of any translations being necessary. And the problem is I can't do that because I get this for a DNS entry. Well, to answer your question, Steve, couldn't we just talk to our ISP and say, hey, can you add another DNS entry for us so that if I'm coming from here, you give me a different reply? You give me a 172.31.0.2 reply? What would our ISP say to that?
You mean when they stop laughing?
Exactly.
Yeah.
You mean you want
We would need like a local DNS for that, wouldn't we?
Yeah, you got it. You guys hit the nail on the head. That's exactly right. ISP is never going to do that for us because why would I do your private network DNS? Doesn't make any sense. We can't do that for you. Go buy a DNS.
And it would defeat the purpose of not having to go out
Exactly.
to the ISP to get there in the first place.
Exactly right. That's precisely the case. You don't even need me to do what you're trying to do, so leave me alone. Get your own IP or your own DNS server. And Jeremy's right. We just need our own DNS server, and that DNS server knows to answer with the correct answer. And we can control what's in that DNS server, and we can groom it any way we want to reply to traffic any way we want. We could groom it to do lots of great things, like give different DNS answers even for different hosts on the network, or if you come from a different subnet, or whatever we wanted to do. So we still want the world to know the authoritative DNS entry, the rule of all rules for DNS out here on the big bad internet. It still needs to point to 24.217.0.3, but just not these hosts. So we can't fix that here. It's not something we can fix in this lab, but it is something that definitely represents a problem. It was really good that your instinct was, we should check this, we should check that. So in a sense, our customers can get to our website, and that's all fine and great. Our internal users can't. It's not the end of the world, and it's not something that was considered in this lab. It didn't need to be solved. It didn't need to be solved in this lab, so we didn't solve it, and that's okay. Not okay that it doesn't work, but it's okay that we didn't solve it, and it uncovered a really important point when it comes to both NAT and external, internal traffic, and even a web server that does the things it does. I mean, a case could be made, depending on the size of your company, that web server should only be the public-facing web server, not the private-facing. We should have a different one for private-facing, even if the website's identical. Or you've got a web server that's basically publicly accessible, and you don't even have it living behind a firewall. There's no protections. So there's a whole slew of things you could go into on this. But this is just dipping our toe in the water. So Instinct is excellent on this. I really appreciate the fact that you folks are participating and you're being really thoughtful about it. So just to double check though, did we do everything we're supposed to do in our rules? I feel like we could have missed something.
I'm reading it now.
Yeah, take your time. If it's
Checking it off as I go.
No, it's in there.
Did we forget to configure the network on the router, the 172.31.0.0/24?
Let us see. And if you look, VLAN 31, SVI, VLAN 31 has it on there. So I think we're good on that, but let's pop this bad boy up real quick. Show IP route. There's the 172.31. And if we hadn't, none of this would have worked, right? We would have never been able to communicate with the server. So we did that. That part's good. Let's see, show, and it's in the routing table. Oh, I just did routing table. Show IP interface brief. Same thing though, up.
We made configuration changes since we last saved. We should probably save as well, even though that's probably not the answer you're looking for.
No, but it's a good
It would
point.
be best practice to do that.
Yeah, very good point. We needed to do that. Anything else?
Do we still have an old default route on the router, or did you already change that when you
Let's see.
put in the 24.217?
So here's what's interesting. We have the correct gateway of last resort to network all zeros. But here, let's look at it this way. Show run pipe include IP route. What do you see?
There is the old one there.
Yeah. So it turns out that old one doesn't have any influence because there are no networks that, this is the old one, because there are no networks connected to us and up that are participating in that. So it doesn't do anything, but it's really sloppy to leave it in there. You would never leave that behind. You would always clean that up. And remember, we didn't type this in. It was by virtue of the fact that we had that DHCP action going on that got installed. But we definitely want to clean that out of there. That's not a good thing to keep in. So let's get rid of that. Whoops. Config T. No. This one. And paste it, and it should be good. So now we have just the one. And hopefully I didn't delete the wrong one or everything's broken again. Let's see here. Yeah, looks like it's still working, so that's good. So that pretty much covers it. I think we nailed down all of the points we needed to nail here. We really dove in really well into a couple of those different things, those little nuances. So that's really cool. I'm content with that. Here's an interesting one, just for grins. If you recall, we built this engineering server, and then we said, hey, we don't want anyone outside of this subnet to be able to configure or manage this engineering server. I wonder if this is covered and you also can't get to it from here. Because we checked and made sure we couldn't get to it from any of the other segments. And we know we can't get to it from the internet because there's no static translation to hit the server. But just for grins, let's just try that real quick. Can I even ping?
I want to say you could because we didn't change the ACL for it. Just thinking out loud.
Sure, absolutely. I don't see an IP address on this. I think I messed something up. Yeah, I must have broke something when I saved this. Shoot, what was this? Let me pop an IP on there real quick just for grins. 3, 2, and 4. So let's give this 5. 172.16.0.5 subnet of /24. And we're going to need to give it a gateway. That should be on there, so I apologize. Something got sloppy, I guess, maybe when I saved something or something like that. So let's try and hit it from here. Ping 172.16.0.5, I think we said. Yeah, it's pinging. But maybe, I don't remember what we even set up for our rules. Let's try this one. 172.16.0.5. I can ping it. What are our rules?
I think it was just telnet.
Yeah,
if I remember correctly.
I think you're right. Let's say show IP access lists. Engineering security, yeah, you're not allowed to telnet to it. So, oh, and it's wide open too. Apparently my deny is not even in place. There's no deny. There's an implicit deny at the end of every access list, but if you have one that says allow everything, you never make it to your implicit deny. So I have clearly goofed something up. I broke what we did in our last lab, or I think it was the last one we did together actually. So let's, just because we don't have enough time to open a new lab, we're just bang this out real quick. We'll fix that real fast. So let's put the deny back in place. IP access list extended, engineering security, no 20. Actually, let's just do it like this. 20, deny IP any. No 20. Picky. Show IP access list. Now we have a proper deny. Should be able to hit it from anything within the same subnet because it shouldn't need to go through that ACL. 16.0.5. I can ping it, which is what we want, right? Within the same LAN, they said it's okay. But outside of it, we didn't want to be able to do it. Now we're getting a destination host unreachable, and we're getting it from our gateway. So that's a good sign. Now I think we got that bad boy working the way we wanted. Check one more subnet before we check the server. Ping 172.31.0. Oh, goodness gracious, not 31. 16.0.5. Can't reach it. That's a good sign. And now let's try it from here. So again, we didn't do anything special for the ACL for this server or his subnet or VLAN. We just fixed the fact that I broke the dumb thing and didn't correct it for some unknown reason. Can I ping 0.5? Now we're getting unreachable. So no, we didn't need to do anything. Looked like it was covered. And if we go to show IP access list, we'll see a bunch of matches on the deny. And that's another interesting point, actually, is there's an implicit deny at the end of all ACLs. This one up here, if you don't match, you hit a deny, but it doesn't get logged on the implicit. So a lot of times it's best practice to go ahead and put the explicit deny so that you can see when your matches are getting logged. And you can say, hey, am I hitting this ACL? What's a quick way I can check it? Okay, send your traffic now, and then I can watch that number increment, and then we know. Does that make sense? Cool. All right. I think that covers it. Does anybody have any other questions or any other thoughts or anything you wanted to see us do here that we didn't do? Or, hey, could we have done this or done that? Any thoughts on that one? Okay, must have been pretty thorough if no one has any questions or ideas. So rather than just drag it out or try to open a new ticket or a new lab that we'd not be able to get done, it'd take us quite a while to get done. I think we'll call it here. As far as I know, it still qualifies. I don't know, Dennis, if you're back yet, if it qualifies for the appropriate amount of time to get the credit, but we're just short of 2 hours, so I feel pretty good that we did good work here. And frankly, whether we get the credit or not, if people get something out of it and enjoy it, good enough for me. So,
Sounds good.
any parting thoughts? Anybody need anything? Any ideas or concerns? All right. Well, like I said before, I really appreciate you guys. Thank you so much for being on. I hope there's some value there. I know some of this is redundant. Some of this you may already know. Shoot me questions if you have any, if you're curious about anything, or hey, could you ever do this in a lab? We'd love to see that. You could even shoot me ideas. I don't care. We're going to try and keep putting these things on as we're able to, hopefully at least 3 or 4 more this year. I'd love to do even more than that, to be honest with you. And we'll see what happens. So appreciate it and enjoyed you guys' company, and I can't wait to see you again soon. Everybody have a great night.